I am continuing the session which I had stopped earlier. One of the things I mentioned is it is about the support bush that was required for putting one jack onto the part of a chassis of some vehicle. The chassis has a rectangular cross section tube which is probably, it says probably it is 1¼ inch wide, depth is sufficient depth which is probably 3 inches, 1¼ inch wide and 3 inches depth, because that is the beam cross section. And at the bottom we have a plunger which belongs to the jack. The jack plunger has to align itself to that. So, considering all this and after taking my concept drawing which I made earlier, our fabricator, or in our case there we have a small workshop on the premises, they have come out with this dimension. So, one of the things which I mentioned a little earlier is saying we start with a stock material which is a 50 millimeter square. So, now I will try to see if I can model it here. So, if I see here I am starting with the top view, and there are several ways of doing it is there. One of them is I can in fact talk with it directly, because it is a solid modeler, it may be appropriate for us to start directly with a solid. In my case, see here I am looking at it at the bottom. I have a 50 mm cross section and height being, the job height is actually 34 millimeters, and if I now come here, you will notice that the basic what do you call raw material is ready. I will just need to modify a little about the background color. Yeah, this is better. You see here, this is the basic raw material within which I have started it. So, if you have to dimension it, automatically whatever the dimension which I have picked will come there. Now, in this I need to make a 31 millimeters groove front to back. So, at the corner, if you see I have here at the corner this world icon axis. So, I have a x which is conventionally left to right is x and y is front to back, and then a z quadrant which is top and bottom. So, if I now put it in this mode, I see that I have this nice thing sitting here. Now, I need to make a groove which is 31 mm wide and 11 mm deep. Now, you see here looking at the and this point and trying to make another solid to do the thing will be slightly tricky. So, in that case what I do is I will try to create a solid by entering all the dimensions manually. So, I have this typically the center line, I offset this by that being 31, I need to offset it by 15.5 millimeters on one side, another 15.5 millimeters on the other side. Now, I need to make a depth of 11 millimeters. So, easiest thing for me will be to join these two ends. The snap setting has been made such that it is half millimeter snaps, it will not accept those things. See here, because of the rounded off grid and 31 half of it is little less, it does not come well. Now fortunately for me, I can make a rectangle using the built in provision. Now I try to create, you see here, if you see top to bottom, it is more than 10 millimeters, something which is required like this is there, and then after that I try to now create, this whole thing is a rectangle. Now if I go to the other view, I will notice that it is sitting here. Using this I make a, see here, what I managed to make is one more intersecting solid with which I can remove the material. Why I am showing you this is exactly the way the fabrication shop works here. Now the only thing is, this is touching here, you have seen this, this is almost touching here. Now I need to move it to a depth of the necessary depth, in this case this is 11 millimeters. Now I have two solids which, if I make the difference, see my first cut top groove is ready. Several advantages it has. One of first of it is perfectly to scale. Second thing is, it follows a little bit of the operation sequence which we do in the workshop. Now there needs to be a groove at the bottom. In this case I have measured it out, saying it requires a hole of 22 millimeters. So it is just logical for us to make an opening like this, such that this is the one that goes and sits on top of the plunger at the bottom. So in principle this is sufficient for me. And that needs to go to a depth of some 16 millimeters it says. Okay. I will see how deep I can go with this. Like before, I try to make a cylinder by extruding the same planar curve. Now once again I try to do the same. Difference see here something functionally what I want has come. On this side there is an opening, and this can go sit and directly sit on top of the plunger, and for purposes of drilling a hole and making this easy, they have also made a radius or a diameter of 15 millimeters, and they have removed this material. Now I will get back to this and say why it is this is typically a process requirement. when they try to drill a hole here, instead of using a milling cutter and try to make the end mill do the job, it is very conventional for us to generally try to make a small pilot hole using a regular drill which has a twisted cutting edge. It is much faster and much easier. You see, the basic functional thing is now ready for us. But then that next little small thing, after conceiving the part, next possible small thing was thought of, one of them saying, all this extra material all around, first of all it makes it heavy and possibly interferes with something else which is around. So, it was decided that we remove all the material around, just leaving only a little bit of around 5 millimeters all around. So, a outside diameter 33 cylinder was prepared. You have seen this. Now, I will come to the more interesting or these are tricks which actually are not, this is not the way to do it, but still it is very convenient for us. I will try to now make another box around it. This is just used for what you call removing material all around. You just watch, I am just trying to make an annular piece from this solid. I remove this. Now, I have something which I will use to remove the material all around from this. See here, this could have been done in a different way, but right now let me proceed only using the very simple Boolean difference. From this object, I remove externally all this material. You see here, what I wanted to make has been created. I am sure it would have been easily possible for us to do several other ways. One of the ways is trying to make a cross section of this, extrude it. That extrusion and that systems will come if actually in reality we are having an extrusion, and afterwards drill a hole in the extrusion. On the other side we make a pipe and fit it to that, and in one shot equivalent thing would have been produced very easily. And now to make the extrusion, I just need all these 4 things and then take it along here, and then to make this pipe I need to have the internal and external dimensions, and eventually when we join them together we will have the same job which has come here. Yeah, I hope you are with me at this point. This has been created in one way. There are any number of ways in which it can be created. Now, what we generally choose is depending on the thing which we are familiar with. If it is a extrusion, imagine I have now, I go to this surface and try to extract this surface. You see, I have a surface here, I have extracted. Similarly, I have another surface here. Now, if you see here, the same object can be prepared by using these things. If it were a, what do you say, a steel angle or a steel C-section or some other thing, I have all the necessary information which is already built into it. Instead of going the other way, I take this, try to make see same thing has been achieved here. And why one is preferred over the other is that one was based on a 40 mm square of length 36 mm. In this case, let us say I already have some usually an extrusion of the nearest size. Imagine I have a C section which approximately has the same this thing here. I can use this C section, cut it to length, and at the other side I have a small pipe, and pipes of various diameters are already always available. See, in principle it is the same object which I have created. I have hidden the object, I will try to show there, and in the middle there is a 15 mm hole. Now, I will try to make the hole here. So, as before I try to make a cylinder and see what best I can. So, diameter of the cylinder is 15 millimeters. This is the opening I am trying to make in this. Now, as before I try to make the union, I am sorry, the subtraction from this, you see what happens. I have the same object created by a different method. So, what is the difference? One of the first things in the difference is I have a probably an extrusion, in this case a C channel of internal width of 31 mm, which is typically that 1¼ inch I am talking about, is all that is required, and this thickness really does not matter. I get things which are 3 millimeters and 4 millimeters wide. So, a C channel, I have used the profile of the C channel to take it forward and show you that whole thing is possible, and at the bottom I have attached a tube to this. You have seen this, and in this case comes the quite important thing, saying this is where our CAD packages are able to really make a difference, where I can do a filleting which is equivalent to the welding operation that we carry out. Actually complete the boolean, now it has become a genuine full fledged solid. Now, when I do the filleting operation, see what will happen. Now, my job with taking a cross section and then trying to what you call weld it to this, and then eventually drilling a hole is ready. except that is in this case probably this drilling a hole is redundant. I do not need this hole. You have seen that just to make it compatible with the earlier thing I have gone through these operations. Strictly speaking, I do not need this hole in this case because I just have a tube here, tube or a pipe, and then I attach it to this. This hole was actually a process dependent hole, which in reality I probably do not need this. That is where advantage is, we can always this is all that is required, a small section profile, then I have a tube welded to it, and after welding the tube, as before I try to see functionally this is very good, absolutely no problem, which is exactly similar to the earlier job, except that in this case the fabrication has been based on a different type of processes. So, you see here both are about the same. This one has been done by milling. In the case of milling, there still will be a small what do you call fillet, which I will try to show you because it is not easy to get into this. The milling part of it is on the groove on top side, bottom one is by turning it. What they have done is, in fact they have done it in reverse. They have first completed this turning operation by holding this flat in a forja chuck and completed that, then held it inside and they have got it. You have seen this, there both of them are a little exactly like what we are looking for. Now, to make the thing a little more presentable, I will fillet all the edges to make it such that as part of the rendering oh the bomb is mine. See, here we have a generally very presentable object, which is most likely this is how it is going to appear for us. Looks easy, is it not? Both are functionally equivalent. This process requires a small opening because we can drill and do this. This process instead directly uses a profile which is extruded, and then once it is extruded we take this pipe and weld it to that, and we have reasonably good stuff here. You have seen this? We have two objects which are created from two different materials. Then what is the change, which will come back to once again our drawing here. One of them, the material I have mentioned saying 50 mm by 50 mm square of length of 36 mm. If you directly take this, it is valid only for one of the type of operations that is mentioned there. The other operation was having, there are two parts of it. The one part of it is the C profile. So, several C sections are available, and generally C sections, some of them depending on their cold roll or hot roll, the dimensions and all are slightly different. Cold rolled ones generally will be very true. So, if this is the section, there will not be any, most of the time these edges will be very square, the edges will be square in the case of a cold rolled sheet. In the case of a hot roll, there will be a very peculiar profile. depending on the amount of precision required and depending on the condition and the tolerances, we can directly use one of those cold rolled ones, cut it to length, put it on top of another pipe, just weld it all around. So, in the long run this much better than the original thing which I tried to conceive, saying I take a sheet metal, bend it into a U, and then I take another what do you call something else pipe and attach it to that. This is where when you create a solid model, if you create it properly the first time, it can be used for all other operations. So, if you pass it on down the line, there will never be any surprises and you will not make many enemies when you look at it. Now, let me do a little bit of if you see here, we end up with having to dimension these parts. Now, we come to the all important aspect of how to dimension these parts. Fortunately for us, this is where these what do you call CAD packages are useful in one way. This is where the CAD packages are also a little bit of a problem in some way. One of the obvious advantages is we can directly pick certain features here and then try to have them dimensioned automatically, but they still those dimensioning conventions which you have learnt earlier are still valid at this point. I will try to give it a what do you call small attempt. For the matter of convention, I switched off the whole grid and allow me to see whether I can, it is possible for me to dimension this. So, as explained to you earlier, we need to give the smallest first here. You see here it shows it is a 9.5 millimeter limb here. And again keeping with the same convention, I will show a groove which is 31 millimeters, which I have shown you. I will raise it a little above so that it is easier for it to understand. Both ways are equally good. One way I can keep both of them in line, so we know what it is. And finally comes to the I have tried to keep whatever I have showed you, saying I take a stock material of 50, then I add this what do you call one limb here and one limb here. Here there is a provision here, see here something has got added in that, saying this is the basic stock material, meaning we do not need to inspect it and carry out any other operations on that. Same thing here. Now we come to the depth of the groove and the height of it, though it is convenient to directly show it here by another what do you call convention. Rarely we show anything inside the object. I will come back to it later, because other features it may interfere with the other features about it. Now, this clearly says take the stock material of 50 mm by 16 mm, which is incidentally also the original stock material. Same here. We just need to cut it to length and afterwards make a 31 millimeter by 11 millimeter groove inside. Depending on the method of operation, it may be needed that I show this left dimension, or it may not be needed that I show the right dimension. The necessary dimensions are all already have been extracted from the drawing here. Now, I will come back to the other thing. You see again at the bottom we have something else here. At the bottom, the total length of the object also needs to be given. See here, it typically shows the length of the object and there is no opening here, and then we again have this radius here. I will see if it is possible to do the radius here. Yeah. Anyway, I am not able to position it properly. It's if I play around I will get these things, which now brings us back to these two openings here. Yes, in this here I have an opening here and I have a opening here. Now, depending on the type of dimensioning features, things that are available, it is very much possible for us to indicate the other dimensions directly here. So, by carefully trying to place it the way we wanted, it is possible to indicate all these things. Now, one of the things you all notice is all the features that are required here are mentioned here, all the features that are required here are mentioned here, depending on, as I have said earlier, my job is very much ready. Got my point so far? This particular what do you call package which I have managed to just download the trial version does not do a very good job of it. However, when you take a printout, it is possible for you to make a 4-view drawing and get all these features all into one drawing as you like. Why I have started with this is, now let me go back to, let us say I need to modify something here. If I need to modify something here, this has been a 3D solid as I have told you earlier. It is not easy for me to actually get the other modifications which I am trying to do, because that is a shortcoming of this particular package. Now, instead I will go here and see whether I can alter these things here. If you remember, I had dimension and this showed me 9.5, this showed me 31, this showed me 9.5. Once if you have made a drawing of one of these profiles, advantage of using these any of these CAD packages is I can easily see what I have done. I have modified this such that it has stretched itself across, and in this case I have not taken care of the dimension. So, now I will take care of this dimension also, and now all the defining points of the dimension are also there. See what has happened, total length has changed and proportionately the width of this has been changed. I can avoid this by one more time by appropriately selecting these control points which are there. If I want only the total length to change, I need to select the various other things like this. And you see here, if you see that 9.5 has not changed, but the other features have changed which is related to this. This has happened because it is a surface, and surface you cannot really pick all the points. I will continue with this what you call exercise in making. We will take a break here. I just wanted to demonstrate to you the main advantage of trying to use solid modeling for us to conceive of a actual object which is useful. What looked like a simple bush which can go on top of another thing, obviously there are so many ways of making it. One of them in this case we have taken a stock square, 50 mm square. It would have been possible, for example, I can take a stock round which is maybe around 37 mm and try to just cut a groove through that, that will be equally useful product for us. In that case, various other things including trying to make these various other settings and all are probably saved a lot. So, I will take a break at this point, we will meet again. So, thank you. What I have covered so far is how to have a concept of what an object is, and then different ways of making it. There in this case I have shown you actually two ways of showing it here compared to my original thing, and finally even at this point the moment it comes here, as we develop we will notice that we can take a extrusion and then on that we can take another pipe, probably weld them together, drill holes and get the whole thing going. So, thank you. I will continue with this in the next session. So, thank you.